Solutions to systems of equations. Let's hurry and review what a system of equations is. An equation, first of all, can be written in two different forms. We have standard form. That's when the x and y are on the same side. So here's an example. 2x plus 3y equals 7. That's standard form. The x and the y are on the same side of equals. The other form that we've talked about is slope-intercept. And slope-intercept is y equals mx plus b. M represents the slope, and b represents the y-intercept. That would be where your line crosses the y-axis. So, if you're in standard form, if you're in slope-intercept form, it doesn't matter. Those are both linear, meaning that if you graphed them, they would create a straight line. So, a system of equations is when you have two or more equations. So, for example, here would be a picture of 2. 1, 2. That's a system of equations. You could even have a third line. Bam. That would be a system of linear equations. Today we're going to talk about how can we tell how many solutions a system of equations have. And we're going to specifically talk about two equations at a time. So let's say we want to know, when do we have exactly one solution, and what does that mean? Well, in this first box, I am going to draw a picture of a linear equation. This is going upward, so it has a positive slope. Now I'm going to draw a picture of another linear equation. This one has a negative slope because it's going downhill. These two linear equations have exactly one solution, and that solution is right where they intersect. So this point right here is called the solution to these two linear equations. We always write a solution as an ordered pair, which is x comma y. So in order for a system of equations to have exactly one solution, they must intersect. So they must intersect. Now, without drawing a picture or graphing the equations every single time, is there a way to know if they're going to intersect right off the bat? Here are some helpful hints. Slopes must be different. If you have two equations and your slopes are totally different, they will automatically intersect each other and have exactly one solution. The next situation would be no solutions. Here's an example of no solutions. There's my first linear equation. There's my second linear equation. And you'll notice that they never intersect. Now we know that the solution is where the two lines intersect, and so if our two lines are never intersecting, that means there's no solutions. They have nothing in common. So our little helpful hints, they must have the same slopes. So slopes must be the same. I'm going to underline same right there because that's important. And then the one before, I'm going to underline different because that's important. Slopes must be the same. And this one has a second piece of information. Y-intercepts must be different. Let's talk about y. If you have an equation and the slopes are the same and the y-intercepts are the same, they're going to land right on top of each other. So you need to have different y-intercepts so that it separates the lines apart. Okay, the last one is infinitely many solutions. Here's this case. You have a linear equation. You have another linear equation. Now watch. They are landing right on top of each other. So if we think about all the points, remember how a line has all of these points. That means the green and the yellow line have all of those same points in common. So this would mean infinitely many solutions because all of their points are the same. And so these would have to be the same exact line, which means if it's the same exact line, they're going to have the same slopes, and they're also going to have the same y-intercepts in order to be the same line. So again, if you have a system of equations that has two equations, you have the option of getting one solution, no solution, infinitely many solutions. So let's try one. Let's say that we have a system of equations, and let's say that our first one is 2x plus 3y equals 12. And let's say that our second equation is y equals 2/3 x minus 4. We are wanting to know, does this system of equations have exactly one solution? Does it have no solution? Or does it have infinitely many solutions? This is what we're trying to figure out right here. Well, in order to tell, both of your equations need to be in slope-intercept form. You can't tell if they're in different forms, so we need to take this top equation and we need to turn it into slope-intercept form. So 2x plus 3y equals 12. My goal is to get y all by itself. So I am going to minus the 2x's to the other side. Bam. So now I'm left with 3y equals negative 2x and positive 12. Last step, divide everything by 3. So now we are left with y equals negative 2/3 x, and then plus 12 divided by 3 is 4. So now let's see what we're actually comparing. We're comparing this equation, y equals 2/3 x minus 4, and this equation, y equals negative 2/3 x plus 4. First things first, let's look at their slopes. Are their slopes the same or different? Slopes are different. The reason they're different, yes, they're both 2/3, but one's positive and one's negative. So one's going to go up, one's going to go down. And now let's look at their y-intercepts. We have a negative 4 and we have a positive 4, which are different. So that means that our y-intercepts are different. So if our slopes are different and our y-intercepts are different, according to our table that we just looked at, that means that both of our lines have different slopes. They're going to cross, which means you are going to have one solution, exactly one solution. If our slopes were exactly the same and our y-intercepts were different, that would mean they were parallel, so no solution. And if we had the exact same line, same slope, same y-intercept, we'd have infinitely many solutions. How can we tell if a point is a solution? So let's say we want to know, is 4, 11 a solution to the system? Remember, 4 is the x, 11 is the y. In order to be a solution, it has to be true for both equations. So I'm going to check. For the first equation, we have y equals 4x minus 5. And I am going to input some numbers here. Well, in for y, up here, y is 11, so 11 equals 4. And then in for x, x is 4, and then minus 5. So now we math it out. 11 equals, okay, 4 times 4 is 16 minus 5. And then 11 equals 16 minus 5 is 11. So that means it works for the first one. Now let's try the second one. Y equals 2x plus 3. I'm plugging in 4, 11 still. So in for y, we know y is 11 equals 2. Plug in for x, x is 4, and then plus 3. So 11 equals 2 times 4 is 8, plus 3, 8, 9, 10, 11. So 11 equals 11, true. So that means, yes, 4 comma 11 is a solution, which here's what this means. One of your equations looks like this, one of your equations looks like this, and the solution is 4 comma 11. That's where they intersect. Let's try one more. Let's say that I give you 2x plus y equals 4 and y equals negative 3x plus 6. And I want to know, is 2 comma 1 a solution? So this is what we're trying to find. Well, here's how we check. In the first equation, we have 2x plus y equals 4. And we're going to be plugging in some numbers. So 2, instead of x right here is 2. So 2 plus, in for y over here is 1, and then equals 4. Okay, well, 2 times 2 is 4, plus 1 equals 4. 4 plus 1 equals 4. No, that does not work. Well, if it doesn't work for the first one, then you can stop, because it has to work for both of them. So no, 2 comma 1 is not a solution. It doesn't work for the first one, which means it's not going to work for both of them.